I've had several questions about biasing tubes and biasing transistors, and I think it's important to keep in mind what the purpose is in biasing either one, Class A. And that is, we have a small signal that we want either a tube or a transistor to amplify undistorted. Here I'm representing a correct DC bias with this green area. And I don't care what the level is right now. All that I know is that it's the correct level, and I don't care if it's positive or negative right now. Now this bias level is usually delivered with a resistor or a network of resistors. Here a capacitor has been added to this circuit, and that value of the capacitor has been chosen so the signal that we want to amplify, shown here as the sine wave, will easily pass through that capacitor and then be added and subtracted from the DC bias. Here you can see that the signal fits nicely into this bias window that I've drawn, and whatever the device is, since this is the correct bias, should have no trouble at all amplifying this signal. Now I want to show some problems that can occur when you're designing a circuit. Here you can see that we've still got a bias voltage here, but the signal is way too strong, and as you can see, both the top and the bottom of the signal are outside of the bias window, and the output should be about at least 10 times bigger, but the top and bottom is clipped, and of course that is some major distortion. Here's another problem that can occur, as we don't have the correct bias level. It's set too high, and we have a signal that's not too strong, but because the bias level is set too high, the output still gets clipped. Here's another problem that can happen. The bias is set too low. We can see that the signal is okay, but because of the bias being too low, the output is being clipped again. A good way to start learning about how to bias tubes and transistors in your own circuits is to take a look at a lot of already existing circuits that have been engineered and tested. Now here's a wiring diagram, and if we take a look at the output tube, the 1LB4, we can see that the grid voltage is 0.0 volts, and the control grid voltage for the 1LH4 is 0.1 volt. R3 is the resistor that supplies the bias voltage for the 1LB4, and C8, that is the capacitor that the signal passes through to the grid. R7 is the bias resistor for the 1LH4, and C5 is the capacitor that the signal travels through, and in this case it's from the volume control. Here's another example of a tube amplifier. If we take a closer look at the 35L6 and the 12SQ7, we can see that the 35L6 grid voltage is 0 volts and the 12SQ7 grid voltage is minus 1 volt. This is the bias resistor for the 35L6, but there's also another resistor, this one right here. It's known as a cathode resistor that also influences the bias of the grid of the 35L6. And this capacitor is the capacitor that the signal travels through to the 35L6. And here are the biasing resistor and the signal capacitor for the 12SQ7. Here is a transistor circuit, an NPN. Let's take a look at the output circuit. We take a look at the base of each transistor. We can see that it shows 0.1 volt positive as the bias. And if you look in between and take a look at the emitter, there's an emitter 10 ohm resistor that goes to ground. That's the same idea as the cathode resistor. And all of this influences the bias. Now if we take a look at the driver circuit, it doesn't show a value for the bias. That 6 volts is the working voltage of the capacitor. That's the signal capacitor that transfers the signal we want to amplify to the base. So what I did was I looked around at other examples where the collector and the emitter had the same value, and I found several examples. And I also took a look at the resistors of both circuits, and it looks like the value should be right at 0.4 volts as the bias on that transistor. Now here is the biasing resistors and capacitors for the driver, and up at the top that is the signal capacitor that allows that signal to be applied to the base of the driver. Here's a PNP circuit. Notice that the voltages are negative, but the biasing scheme has the same architectural stamp as the NPN. So as you're learning how to bias tubes and transistors, keep in mind what the purpose is.